Now we are starting question number 6 for this topic of transformation for P1. A curve has an equation y is equal to 3 cos of 2x plus 2 for x going to lie between 0 to pi. State the greatest and the least values of y. B. Sketch the graph of y is equal to 3 cos of 2x plus 2 for x greater than or equal to 0, less than or equal to pi. C. By considering the straight line y is equal to kx, where k is a constant, state the number of the solutions of this equation 3 cos of 2x plus 2 is equal to kx, where x lying between 0 to pi in each of the following cases when k is equal to minus 3, when k is equal to 1, and when k is equal to 3. Since we are going to get the values greatest and the least values, where x range is given there equal to 0 to pi. So we will put these two values at the ends of these two graphs into this equation. So y equal to 3 cos of 2x plus 2. The range of this graph is from 0 till pi. So if we put 0 in this value, then it should be equal to 3 cos of 2 into 0 plus 2, and that thing will be equal to 3 cos of 0 is 1 plus 2, and that thing is equal to 5. That is going to give us the greatest value of this equation there. Now the least value of y will be equal to 3 into cos of 2 into pi plus 2. That thing is equal to cos of 2 pi is 3. Where is this value? Stop. This value is also equal to 5, but this is not the greatest, sorry, least value. So we put for pi value equal to x is equal to pi by 2. So y is equal to 3 cos of 2 into pi value is pi by 2 plus 2. So this value is equal to 3 into cos of pi plus 2. Cos of pi is basically equal to minus 1 plus 2. So that thing is equal to minus 1. So this is the least value of y there. So the range of this graph is from minus 1 till 5 is the values of least and the greatest values of this equation there. Then they are asking about sketch of this graph. We know that y is equal to 3 cos of 2x plus 2. Let's say we draw the graph of, because this is 2 pi and we are going to get only up till pi, it is 1 and minus 1. So this is the graph of cos of x from 0 till 2 pi. But we have to get the range from 0 till pi there. So the graph of this would be from this value up till pi, it is 0. So it is 1 and this is minus 1 of this graph of cos of x. Then cos of 2x. This means every value will be double there. then into 3. So every value is 3 times of this graph there. Then plus 2. So this is the graph of final equation 3 cos of 2x plus 2 is the final sketch of this graph. Then they are asking in the next part, find the number of the solutions when 3 cos of 2x plus 2 is equal to k of x. And they have given the different values of k there. Now we will find, first of all, because they are both equal to, let's say we can make it equal to y. So we are going to make the graph of this 5 minus 1 till 1 of this curve y is equal to 3 cos of 2x plus 2. Now the first part, y is equal to kx and k is equal to 3 minus 3 into x. So we are going to make the graph of y is equal to minus 3x from this portion there. So when y is equal to kx is equal to minus 3x, so that means the line will be passing from the origin and gradient is negative. So this is the graph of y equal to minus 3x. Since there is no point of intersection, so it has no solution to this problem. Then the second part of this graph is when k is equal to 1. So y equal to 1 into x, that is equal to x. So that means it is a line which is passing from the origin and it is cutting this graph at these 2 points. So this has two solutions to this problem when y is equal to kx or k is equal to 1 for that. And in the third part, when k is equal to 3, then y is equal to 3 of x. Then again it will be a line passing from the origin and it is cutting the graph at this position. So this means it has only one solution to that problem. So this is the solution of these graphs with respect to these three parts when k is equal to minus 3, when k is equal to 1, and when k is equal to 3. And you are getting two solutions, no solutions, and one solution for this problem. And for the next part, functions f, g, and h are defined by x belongs to the real numbers, where f of x is equal to 3x, 3 cos of 2x plus 2, g of x is equal to f of 2x plus 4, and h of x is equal to 2 into f of x plus pi by 2. Describe fully a sequence of transformation that maps the graph of y is equal to f of x on to y is equal to g of x. This last part, describe fully the sequence of the transformation that maps the graph y is equal to f of x to y is equal to h of x. Now we are finding the combined transformation of this f of x onto g of x, where g of x is basically equal to this first part, f of x onto g of x, and g of x basically equal to f of twice of x plus 4.